All right. So now we are going ahead. We will go ahead to look at the discriminant, only the discriminant, which is again b squared minus 4ac. Okay, and we will determine the number of roots. Is it two real roots, one real root only, or no real root but with two imaginary roots? Okay, we'll see. Now, just like before, you can go ahead and write down the ABC values. I would say it's optional at this point. If you want to if you think you can handle these numbers properly, okay, go ahead. Now, I would still strongly suggest you to use parentheses if you don't write this, okay? B squared minus 4AC, okay? And then you have 4 minus 4 minus well, no, plus 12 actually, because the negative and negative, that gives you a plus. So you've got 16. Okay, it's a number bigger than 0, it's positive, so the conclusion would be we've got two real roots over here. Okay, two real roots for question number 1. Okay, what about question number 2? So for question number 2, you've got A, B, and C. Okay, got A, B, and C. And then, so B squared minus 4AC, B squared minus 4AC right here. Ooh, that doesn't sound like a good number combination, because now that's something you can see here. If A and C values are both positive, then you've got to watch out, because that means it remains as a subtraction. So what do we have here? 8 times 8 is 64. 64 times 4 is 240 plus 16, which is 256. Okay. So 9 minus 256, okay, you may go ahead and say, hey, that's less than 0. So you got two, so that must be two imaginary roots, no real roots whatsoever. Okay, you can say that. I would also welcome you to actually write down the actual value, but you should be able to conclude that there should be no real roots, and then there will be two imaginary roots. Okay, if we have to find out the roots, okay, we can actually use this and plug it straight into the quadratic formula, okay, if we need to, which we will use it for question number 5. Okay, same thing right here. A, it's 5, B, it's -7, and C is -7. And here, look at C, it's being negative here. So then we can actually say one thing for sure already, which is that there will be two real roots. Okay, if you say, how do you know so fast? See, okay, that two minus signs right there, changing the minus to a plus, and 5 times 4 is 20. 20 times 7, it's 140, so it's 189, so it's bigger than 0. So again, two real roots. Okay, so once you know it's an addition right here, you know, it's just guaranteed two real roots. And last one here, number 4, it's now this one, be very careful here. A is 4, B is, what's B? Okay, C is what? Okay, now for this case, let me go ahead and make sure that everyone is on the same page. When we have 4x squared without the x term and then minus 12, that means this. Okay, 4x squared plus 0x minus 12. And that means we got B value equal to 0 and C value equals to -12. And that means we have B squared minus 4AC, B squared minus 4AC, B squared minus 4AC. 0 plus, yeah, as you can see, it's a plus, so you know it's two real roots. but you still want to show. So 4 times 4, it's 16. 16 times 12, it's what? 16 times 12, it's 160 plus 32, so 192. So it's equal to 192. So that's 2 real roots. Okay, 2 real roots. Easy. Okay, b squared minus 4ac, very important tool. And then let's go ahead and take a look at number 5. All right, number 5. What is it? Okay, we will find out the discriminant and also the root or roots. Okay, so a is equal to 7, b is equal to -4, and c is equal to 7. Now, and when we say we will find out the roots, that means we will set this equal to what number? You know what number? It's going to be 0. Okay, again, you find out the roots, it has to equal to 0. Okay, so we're saying, hey, please find out the x value and y it's equal to 0, just like finding the x-intercept. All right, now let's first take care of the discriminant. Okay, so b squared minus 4ac. B squared minus 4ac. And 16 minus 28 times 7 was 28 times 7. Okay, that is 140 and 56, so 196. Okay, 196, and that will be a -180. So we can say, hey, we have a conclusion right here that we are going to see no real roots, and we're going to see 2 imaginary roots. Okay, we're going to see that. And then we'll go ahead and find out the roots. Okay, so we have we have the quadratic formula, right? We have negative b plus or minus square root of b squared minus 4ac and 2a, right? Now we are going to make things a little bit easier. Okay, we're going to make things a little bit easier because we did some work already. Okay, so we put in the b right here. B is -4. And then we did the work for b squared minus 4ac over here. And we knew the number. So we don't have to do this whole thing again. We can just put -180 over here. Okay, so that would save us some work. And then we have 2 times 7 in the denominator. So we'll say, all right, negative of -4, it's 4. And then, let's go ahead and simplify -180. So because it's a negative number, we know there's an I. What's 180? You know what 180 is? 180 is 36 times 5. You know that? All right, so that means we will have the square root of, also square root of 180. It's equal to 6 root 5. Okay, so 6i root 5, it's equivalent to square root of -180. And then you can go ahead and simplify this a little bit further because they're all multiples of 2. So you can reduce all these numbers with 2. So your final answer is 2 plus or minus 3i root 5 over 7. Okay, so that would be your final answer. Okay, 2 plus or minus 3i root 5 over 7. So that's these are the 2 imaginary roots. Okay, these are the 2 imaginary roots that we will get from this quadratic equation. Okay, so so that's it. Now so that's the notes, but for the next video I would like to go over 2 questions on the worksheet. Okay, so you can flip to the next page, and I want to focus on number 10 and number 12. Okay, so stick around.